Hello, welcome to Stateless Implementers Call 28, issue 1203 in the PM repo. Cool. We can start off with any team updates. Anyone want to kick things off?
Yeah, I can mention that I've been starting to work on EIP draft for binary trees, but it's still in the works to be polished before being shared. So stay tuned. And also, I've been working on some tests, on some new execution spec tests for Vercol regarding some bugs that we found in DevNet 7 in our clients. But yeah, I will mention that later.
One thing I don't remember, did we have a VIC since the testnet launched? Sorry, a SIC now. If we did not, then we relaunched Calstin and DevNet 7. And yeah, please go play with it and break it.
Yeah, Ethereum JS is sort of playing with Constant in 7. And we are also resolving some of the issues that we are encountering, which basically are the updates for the Constant in 7 itself. And we are making good progress on it.
On Bezos side, so not a lot of update. We still can follow the devnet. Luis is still trying to implement the block hash gas cost modification. Thomas is still trying to implement the proof verification. It will unblock some stuff like the sync for Verkel, snap sync equivalent, and also validate the proof coming from the other client. And we are also trying to optimize the stem generation by modifying how we are calling the Rust Verkel library. So we are trying to use multiple times the same address commitment. So we have a test, it's working. It's just to clean the code in order to integrate it into Bezu. We should see more better performance thanks to this modification. And yeah, I forgot to say, okay, so the FlatDB based on stem can follow the devnet and also the legacy FlatDB. So we have two versions of the FlatDB, and we will choose depending on the performance what we will use at the end. And yeah, it's mainly that, I think. Yeah, everything for Bezu.
Cool. Any other updates? If not, we can keep going. Next up, we have a update to the execution spec test, version 0.0.8. Ignacio?
Yes, this will be a quick mention. Okay, so we launched DevNet 7, and after some blocks, Nethermind had a consensus bug, so we debugged that with Tanishq, and yeah, found a kind of really weird case in which, yeah, there was a bug in Nethermind. So I created an execution spec test to simulate that. So yeah, we'll have regressions in the future. And the same thing happened with Besu for another case. So yeah, we dive into the details with Luis and found the situation. And I created another test for that. So this is under the usual idea of like now every bug that we find in every devnet should be a new execution spec tests. So we kind of start accumulating all these situations somewhere because yeah, whenever we launch a new devnet, the previous one is lost. So yeah, and also we are making sure that everyone, like if a new client joins the next DevNet, it's kind of also being covered by all these found situations. So yeah, I see that you already shared the link in the chat. So if you're running execution spec test, please run this new version and make sure that it runs correctly.
Cool, thank you. Next up, on the topic of pre-image distribution and portal, I think we have Piper here who is available.
Hey there. Can you guys hear me? Is my audio okay?
Yep, perfect.
Cool. I had a meeting with Guillaume and the team at DevCon, talked about pre-image distribution, got a decent understanding of the problem. Portal can solve this, but it isn't probably the optimal solution. Portal is currently best when you're looking at clients who want to grab a subset of the data sort of on demand, and my understanding of the pre-image problem is that just generally all of the clients in the network need to grab the full set of pre-images. And so while Portal could solve this, I don't think it is the optimal solution. We talked about a file-based approach. Does it make any sense for me to lay that out here on the call?
Guillaume, what do you think?
Sure. I mean, I think everybody knows about the file approach, but maybe to to sustain the argument.
The Reader's Digest version of it was something around, S3 buckets, being able to generate the file, potentially having pre-coded S3 buckets in clients that are already distributed, being able to distribute probably a signature over the file so that they can have pre-distributed private keys or something like that. There's, the model doesn't have to be exactly that. It's just that there is a model that we can use that kind of has a pre-distributed trust model, and frankly, distributing big files from S3 buckets is a pretty straightforward approach. And even if it's not S3 buckets, torrents, anything like that are going to be a simpler solution than using Portal for it. That's all I think I have. Is there anything I missed?
Nope, that was it. I don't know if Łukasz is here. Presumably, I don't see him. No. Yeah, so I think Łukasz. In fact, I don't think there's anybody from Nethermind. Well, there's Wei, but I don't know if you're involved in day-to-day vertical design decision. But I know Łukasz from Nethermind was really pushing for making a peer-to-peer change to the protocol, or at least having a peer-to-peer distribution system. I think it's pretty clear that the CDN approach is the simplest, and we should go with that. Okay, yeah, I guess there's no more to discuss right now because, unless someone is still adamant, we should go the P2P route. I think we can settle this.
Maybe what we can do, like it's not urgent, but we can make some kind of spec on a potential format for the file that we already have. It's super simple, but I know maybe it helps to move forward a bit more with the idea.
Cool. If nothing else on this topic, we can keep going. Next up on the topic of state expiry, we have Adrian here.
Yes.
And yeah, did you have?
Guillaume told me to come, but I'm not exactly sure what to expect of me.
Yeah, Guillaume, maybe you can prime the topic here. Yeah.
Yeah, so we had this conversation in Bangkok about resurrecting. Like, do we want to resurrect based on reads or based on writes? And you had a lot of reflections about it, like a lot of thoughts. So I wanted to know if you could just summarize what your position is. See if we want to do maybe summarize all the problems the corner cases you found, And
Yeah,
have a talk about it.
so I try to think of expiry and resurrection from my knowledge as a smart contract developer of like corner case in how storage is being used. And most of the storage accesses are kind of like, as someone would expect, like reading and writing. And in that regard, like the question is whether a read would extend the lifetime of an extension or not. I mean, I think the discussion was a bit back and forth with that regard, so I'm not sure if there was any good conclusion. There are a few slots that are being read and never, or basically never written to, like written during the construction of the contract, and then you read them. Most of the time this happened like off-chain, like reading an ERC20 name or symbol, something like that. But I think there are very interesting slots to consider in the case of ERC 721. For those that are not familiar with the details of the implementation of ERC 721, each token that is being transferred as kind of an approval. Like in ERC 721, you can approve a specific token being sent to a specific person. And most of the time, this slot contains a 0, because basically nobody is allowed to take the token. And anytime there is a transfer of that token, what the current implementation does is it writes a 0 to like reset, even if the old value is already 0. Like currently, it's cheaper to just write zeros than to read and decide what to do depending on what you read. And so there is this interesting case where there are slots on the blockchain state that are likely to always be zeros, but depending on how state expiry works, there will be different cases and different cost model, depending on whether the 0 is like an implicit 0 in the sense that value was never written to the state, and possibly there is no extension in the state tree. I'm not sure how it's implemented, but that's what I would expect, compared to basically the same case, except a 0 was written there. And so it's like no longer implicit in the sense that at some point somebody actually wrote a 0. The state of the chain is basically the same, but as far as the clients are concerned, there may be a difference here. One of my concerns as a Solidity developer is how these explicit 0 will be dealt with, how they will expire. Like, will it be more expensive to me to read a 0 if it was never written to, compared to a 0 that has been written a few years ago? And when I'm saying a 0, I'm not just talking about the slot. In that case, like the entire extension would be 0, like the 256 objects in the extension will all be 0. Just one of them may at some point be the target of a nestor that puts a 0 where there was an implicit 0 before.
I have a question in this model. When you do write a 1, so you or something, you give the authorization. What happens to that slot afterwards? Like, is it ever accessed again?
So whenever so let's say you have token ID number 1 and you allow and you approve it to me. So you write my address here. If I use the approval to the allowance to move the token either to me or to a third party, this value, which is my address, will be reset to 0. If you decide to transfer the token and like move it to anybody in this call, the allowance will also be reset to 0. So that way I lose my allowance when the token is moved. So yeah, whenever basically the token moves, this is set to 0.
Mm-hmm. Okay. So yeah, trying to answer your question. When nothing has been written, you read, but like you go with the node does not exist in the tree. So if you read from it, you will find a 0, so you will know it's a 0. I mean, you will know it's missing.
Yeah.
And so you will read a 0, and it will be it will be just the cost of a read. As soon as you write something else, it will expire. Well, it can expire if we keep okay. So just to give some context, there's this rule we want to change, that every read, like the first read that you perform in a group per epoch or era or whatever you call it, will cost the same as of write, and it will update the counter for the whole group. That's what we're considering. So if you have this rule, then you no longer have a problem. I mean, assuming you do read it frequently, because it will always be refreshed. Of course, if you don't read, or if we don't have this first rule in an era is of right, then you will find yourself having to pass the proof, like to resurrect the contract. Not the contract, but that part of the contract storage for your transaction to properly execute. So I don't know if that answers your question.
Well, not entirely, because one very subtle thing you said is, as long as someone writes something else, I'm understanding that as writing something that is non-zero. My question is more like, if the note is not present in the tree, when you read, you basically read as an implicit zero. But let's say that this node doesn't exist in the tree and I decide to write, but what I write is a zero. Will that create a node?
No.
Okay. And if I write a 1, that obviously creates a node. Then later on, if I write a 0, then the node exists and will expire.
Yes.
Okay.
So that's why I didn't make a difference, because yes, there's no difference. Whatever you write there will create the node, and the node will expire.
Yeah. So basically, the all expiring thing starts whenever someone writes something different than 0, even if it's then resetted back to 0. The fact that at some point there was something that was non-zero means that the state of this slot changes basically forever.
Exactly. So if you find yourself like reading this slot very often, every 6 months you will pay a lot more just to refresh the. Okay, assuming we have this thing we talked about where the first first read is also right. You have an extra cost every 6 months.
So that may change. I mean, there are a lot of optimization that may change depending on like the state of the storage structure going to Verkle or things like that. I mean, my personal feeling is that, in my opinion, if I was to write zeros everywhere, I would love the nodes to disappear so that there is no expiry issues anymore. In that sense, that would encourage people to clean the state, and hopefully, like, clients would be able to remove the node directly and not having any kind of garbage collector. But again, I'm not an implementer. I don't know how it works under the hood, so maybe that's not possible.
I mean, this is Han is probably better suited to answer this question. But yeah, the problem is there used to be a lot of proposals like this one where you would just simply delete stuff from the tree, and the complexity explodes. So this is where the approach of 7736 is really nice. You circumvent a lot of the complexity. So I agree, it would make your use case a lot simpler, but there's a lot of core there's a lot of issues that will pop up if you do this.
Yeah. And yeah, just one last thing is, I'm always very happy to discuss with any person that is interested in basically discussing how changes to state expiry will impact like standard contracts that I happen to be writing.
Han?
Yeah, just wanted to give an update as well, since we are talking about the implementation. I think right now what I'm trying to do is to implement the EIP 7736. The current progress is that the changes that the state expiry need on Verkle is done. Now I'm just working on the gap part. So once we get all these components ready, integrated, and hopefully we have some sort of a DevNet ready, then we can start testing out all these scenarios and see how we can make the changes to suit the needs of like certain edge cases or things like that. But yeah, that's still in progress. But yeah, we can talk about all these special scenarios later on. Yeah.
Awesome. Anything else on the topic of state expiry before we move on? Cool. Last up then, we have a potential EIP for stateless transactions that Gajinder wanted to share.
Hey guys. So basically, this was something that came up in discussion when we were in DEF CON and trying to figure out what are the challenges for stateless clients. And one of the challenges would be that they would not be able to do block. So stateless clients which don't maintain any execution state, they won't be able to do any kind of local block building. And this proposal is sort of to remedy that in a limited way, because our transaction execution is Turing complete. So if basically it really deviates from the execution when there is some previous transaction that has been included and it has changed something which basically dynamically affects the execution of this transaction, then this transaction would be at a point where the stateless builder won't be able to include it because it might access a state which was actually not bundled with it. But ignoring that scenario, so there is this. So what we can do is we can, with every transaction, so the transaction submitter will also have to submit an execution witness sort of a thing with the transaction, and that execution witness will have state diff as well as the proof of the state diff, or if that's a stateless transaction, or maybe even a ZK proof of the current execution to produce the state diff if it's a ZK transaction. So basically, these are 2 points that are out there. But this execution witness would also bundle parent state root, which is basically what a builder would look at to see whether it can include this transaction in this particular block bundle that it's building. And even though it might have included some other transactions before this, it can still try to include this transaction, because it knows that, okay, if these are the pre-states that this particular transaction accessed, and if I have made changes to that particular state by including some other transaction, so I know what the pre-state of that transaction is, and and basically it will be able to again try to include the transaction by again doing the transaction execution. And we'll basically see that what are the new diffs that it produces, and these diffs might not be same as the state diff that was included in the execution witness of the transaction, because that part is only used to validate whether the transaction was valid or not. And similarly, if that is a ZK transaction and that has a ZK proof, and that proof will basically be used to only validate if the transaction was valid, because if there is so there are 2 scenarios. If there is any pre-state change, then basically that transaction will need to be executed and the diffs will need to be produced. But for example, if there is no pre-state diff change, then probably since there are no time-based elements that are currently there in EVM, unless we have time delay functions, so one could basically probably just not even need to execute the transaction to produce the diffs, and could just take the diffs from there. Post state root in the execution witness is not really valuable, because even if because the post state root can't be used like how we use it in the block execution witness, that you get a block, you get the end post def post-state root, and then you can basically in a stateless client use that post-state root as the next starting point for the next block. So that is not possible over here. In this case, the execution, the client will have to recalculate if it's doing its own block execution proof. But I think that is something that can be figured out by the client. I'm basically trying to spec it out and trying to figure this out, and also trying to see how it will look for ZK. Either I will just make a single EIP. So I'm basically currently writing the EIP and trying to figure this out. I'll either make a single EIP for both stateless and ZK transaction, or I'll convert it into two different EIPs if it looks quite different. Yeah, that is currently where I'm at.
Guillaume?
Yeah, it's actually more a question for Goti and maybe for Milos as well. Because I remember we had some similar question about Portal. Could we rebuild proofs from, could we somehow aggregate proofs from blocks to provide proofs for single elements? And for the proof, you need all the FIs, which will not be available in a stateless client. So I guess we could have a semi-stateless client where you only store the internal FIs of the tree, which the internal nodes of the tree, which would save a lot of space already. So it would still be beneficial. But I'm just wondering, is it really possible to take just the transactions and recreate the block proof? My understanding is that it's not possible, and yeah, that's a question for Goti and maybe Milos.
I mean, it depends on the proof system you're using, but I mean, with IPAs, not really. Mostly because because the hashes basically kill you.
Mm-hmm. What do you mean the hashes kill you?
I mean, basically, IPAs just are not linear or have any nice structure. That's kind of the problem.
Right. So maybe I was just talking about the witness more exactly. Like setting aside the IPA altogether. You rebuild, like, from all the transactions you've got, you rebuild the view of the tree, which is stateless, and then you have to create a block proof.
Mm-hmm.
And to do the block proof, as far as I know, you need the FIs, like all the.
What are FIs?
It's the evaluation of the function at every single point in the polynomial, which you don't have because it's a stateless tree.
Yeah.
Right, because you're making one gigantic polynomial division, and you need the value everywhere. So we could still have like a semi-stateless builder, which would be because the tree is smaller. But yeah, I think there's a bit of a difficulty here.
Yeah, or if we basically sort of change block basically, so we'll change the tree to store diffs, for example, for an era, and then apply at the end of the era. Maybe in that scenario, we can just accumulate the diffs all along the way, and maybe then somebody who has full state will be able to apply it.
Right, but then you would duplicate the IP proof for every single transaction you've got.
I just want to add that from the portal network, like if you have access to the portal network and the way that I kind of envision it, it would work with the Berkeley tree. You would be able to fetch the data, only the data that you need to prove the transaction execution, or just the data that you need for that purpose. You basically have to fetch the entire inner nodes, so it's not so small, but it should be doable. You don't need the entire state. You still need slices of the state, but you need the full internal nodes, I would say, if you want to create a proof. Or if you want to create a different proof, like specific proof that will be used within the portal network, you don't necessarily maybe need to cache the entire. It depends how it's actually implemented in the portal network at the end, but it might be possible that with a different proving schema, you might be able to have like a smaller proof or something like that, but it should definitely be possible using portal network. I'm not sure about performance-wise if that's actually going to be good enough. Yeah.
So, Game, while building the block proof, I mean, do we require to pull extra nodes, internal nodes, to build that proof? Because
Yeah, I think yeah.
in my understanding, I mean, since it's just homomorphic X, for example, with IPAs, and that would basically that if we can apply and sort of update the tree just based on that.
Yeah, but you still need to evaluate. Like you need to do an FFT, if I remember correctly. I'm a bit murky on the details now, but you need to do some transform, and you need all the values for this to compute. Yeah, I don't quite remember, but yes, I'm pretty sure you need them. I have to reread the code to remember exactly. I can get back to you on that.
Cool. Anything else on this? If not, we can wrap. All right, cool. And this will be, I believe, the last stateless implementers call for 2024 as we're getting close to the holiday season. We can, of course, keep discussion async in the meantime in the Discord. All right. Thank you, everybody, for joining.
Thanks. Bye.
Yeah. Bye.
See you.